All right. Hello, everyone. We are just on time. I'm Gabor from NXP, and I was recently asked to moderate this session, and this is exactly my topic, the vulnerability handling topic, so I was really happy about it. We will hear now three, hopefully very interesting presentations. And the first presenter will be Angelo D'Amato, who we worked together on the vulnerability handling horizontal CRA standard. And I know that he works a lot, and we are in a very tight time frame. So I'm very interested on what will be your common future together. Angelo, please.
Thank you so much. So, can you hear me? Yes, it's working? Perfect. Thank you. Okay, so thank you for the presentation, Gabor. Indeed, Gabor is one of the working group 9 members. And let's start directly with my presentation, so at least you know who I am, for whoever doesn't know me. So I am the rapporteur for PT2 and PT3. PT2 is the CRA standard for harmonized standard horizontal for product security requirement. And PT3 is the topic of today, the vulnerability handling that we will go in deep today in the next 30 minutes. Just to let you know, so my activity are founded with my company Vulnir through the ESMEA fund for the stand for CR. Indeed, there are also other rapporteurs like me for verticals. We will have also Daniel that is managing the browser. We have August and other that they have also founded with the same founding stand for CR. Just as a point, so today we will cover this topic. So we will we will setting up the context on the vulnerability handling, sharing basic information on the standard and the status of where we are. I will show you a little bit of what is the outline, what are the main topics that are contained in the standard today. And in the outline, in the timeline, I will show you also what are the discussions that we are having now with the Commission and with the national standardization body. And what are the next steps for us. Before starting, I'm curious to see how many are already familiar with the PT3 standard. Have you ever already had the opportunity to read? If you can raise your hands, just at least I can understand how I can calibrate the speech. I say quite a lot, I mean half and half, so I hope that for the half that I know you have new information, for the other half you will learn something new and why is it important. I will also leave a couple of minutes at the end for questions and answer. Let's set up the context. So this is important because it gives you, for the half that is new with the topic, I selected some of the news that I think that were relevant to make some of the main points. For example, we have the news about the Fortinet. Fortinet, this is a news from end of 2025, Fortinet fixed some issues, and they delay the notification that this issue were fixed for 17 days, and their customers were exposed for the attack in that 17 days. And this is giving you the idea why it's important to communicate when a fixing is happening and share this information with customers. Another news is about the latest incident. On 28th of February, there was a guy, a developer, expert of AI, that he had a vacuum cleaner, so it's a robot vacuum cleaner, and he decided, okay, let me use AI, ask to Claude, okay, I want to control my device with a joystick. And ask to Claude, okay, program me give me a program that can automatize this and can interface with my vacuum cleaner. The AI answered to this guy, do you want to connect with 7,000 device? And so, with one command that he gave it to the AI, Claude, he had access to all the device. This is giving you an idea that the attack can be also unintentional, and the AI is speeding up this attack path. So we need to be faster. So also our regulation, our standard needs to be fast and more effective under this attack. Another one that I want to highlight is also connected to FortiGate, that this is recent, also 23rd of February. There was, it's not about a vulnerability, an exploitable vulnerability, that there were misconfiguration. There were hundreds of these devices in the network, and there was this person that asked through an AI that was on AWS to do discovery on this device and check misconfiguration. And with one command, he was able to own several of these devices without any effort. This means that we are facing something that is very fast, so exploitation at a speed. I want to show you another information regarding a publication that was recently, they created a website that is called Zero Day Clock, and this is for awareness. There were a lot of companies, Vulncheck, Palo Alto, and a lot of representatives that sit together, and they created a website with some of interesting statistics. Let's just look at this together. So we will have on the right, what is the speed from vulnerability to exploitation? As you can see, in 2018, the time between the exploitation, between a vulnerability that was available and the exploitation itself was 2.3 years, yeah? Something like that. And now, in 2026, is 1.3 days. This means that time is essence. We cannot delay. We cannot delay notification. We cannot delay fix. And we need to make sure that we need also to raise a little bit the bar. And we need to be conscious about that. In the forecast that they have, there is that in 2026, the projected time between a vulnerability and exploit is 1 day. But you will have, at the end of 2026, 1 hour, and in 2028, 1 minute. So, and these are scary numbers. And this is the reason why we need to take more seriously the activity to make our product more secure, to have timely patching, timely update, and make sure that our product is secure by design. And then you can see also the zero-day rate. Even that is increasing. In the last years, with less vulnerability, you have 69% of 0 days. It's very scary. And this is also emphasized by the use of AI that can speed up also the attacker velocity. This is the reason why we have also the Commission that is founding a lot of projects that is using AI to speed up also the defense part. After this context, I want just to go on a figure that everybody of us knows. Is a kind of summary of what are the main obligations from CRA. And you can see that every part starts from a risk assessment. You need to contextualize the risk based on your type of product, because of course a toothbrush doesn't have the same security requirement that maybe a firewall has, like we saw before. And we need just to make sure that we have this balance, and how you can make it with a risk-based approach. In the consumer space, it's something new, and so we need just to educate consumer, manufacturer, market surveillance authority, notified body, and so we need always to share the same page and the same even value sometimes. Even though sometimes you have also conflicting interests, because there are some of the manufacturers that they try to push the bar lower, and then we have the Commission that try to push the bar too high. And we will see this later, because I have a summary of what comments we received. As you can see, you have also the product-related essential requirement, vulnerability handling requirement that we will speak today, and I will give you an overview. And then all the conformity assessment and of course, all the reporting obligation that will be activated soon in September 2026. This is the timeline. This is just to give you an idea that you need to speed up your preparation. It's a simplified timeline. You saw this in many other talks, so this is not something new. But I wanted just to highlight to you that there will be the first rule, Annex 4 of CRA, for the notification of cabs that will be activated in 11 June 2026. We have the reporting obligation. So if you have an exploitable vulnerability as a manufacturer, you need to report this to the single reporting platform. Sometimes there are also a kind of confusion because manufacturers, they say, okay, but what I need to do? Do I need to implement all the vulnerability handling requirement now, or I need to have a subset of this? Of course, it's better that you implement all, that you have S-bomb, that you have all, but of course there should be a balance. So, and this is also based on your risk, your category of risk of your product, and there are a lot of contextualization that needs to happen. And of course, the idea is that we have the standard publication around 30 of October. There will be the vertical and horizontal that will be published, and the enter into application of CRA that is not moving, at least in the 10th, in the NISA conference of the beginning of the month, there were manufacturers that say, will this happen like in red, that we will have the postponement of the application of the date? No. So, and they repeat it many times. So don't rely on the fact that there will be a delay. There will be no delay. So be prepared. This is just an overview of this requirement. I will not go into details, but I was walking around, and then there were people a little bit concerned. I said, but because they didn't see any speech of these days that mobile applications are in scope. Yes, mobile applications are in scope. This is a simplified image. You have sensor, device, application, remote data processing, gateway, whatever you want, is in scope. This is an horizontal standard. So even a mobile game or a gaming only software is in scope. You can find this information in the frequent asked questions from the Commission. That even a software that you put on your website, the place of the placement of the market is when you publish on your website. So I think that you need also to take in consideration this, and this is just for awareness. As you can see in the vulnerability handling requirement, I will not cover the security by design, the risk assessment, but I expanded only the area that we will talk today. So we will cover the identification of the vulnerability as bomb, how to remediate this vulnerability, regular test. You need to inform your customer about the fixed vulnerabilities. Coordinated vulnerability disclosure in place. You need to have a way to intake. A researcher that has a vulnerability on your product needs to know where to look at and where to submit a form that there is a vulnerability in your product. This is a basic step that you have also in the UK PSTI, or ETSI 33645, or others. Secure distribution of updates, and of course, all the dissemination of the security update. These are the main essential requirements. Let's go on the overview. This is a little bit complex image, but this is the same image that you will find in the standard. The colors are confusionary, so we receive also a comment why there are these different colors. So I will also explain better into the standard, but just to give you an idea, this is not something that we created from the scratch. It's something that is coming from the TR 5895 on the multi-party vulnerability disclosure. And I just adapted this image. You can find the one with different color are area that we changed in the standard, that we expanded. The part in white are something that pretty much is similar. We are just small changes, but this gives you a kind of look on where the major part of the changes happen within our standard. And we will not go on each block, otherwise it's not half an hour, it will be 4 hours, but we will have a deep dive where I went one by one on all the essential requirements. We have a website of Center for CR. You can go there, and then you can see all the deep dive for each standard. In the standard, the PT3, to find a balance between the high bar from the Commission and a little bit lower bar from the manufacturer and from the industry, we created something that's called requirement enhancement. It's not something that is new. This is something that you can find into the 62443, okay? The ones that are in blue are the ones that we integrated into the standard. So the other are just example, because of course the concept of requirement enhancement is to have baseline requirements that are the same for all, mobile game, firewall, and so on. A requirement enhancement is a step further that you can select if you are in a more critical devices. So I expected that maybe a firewall needs to have you need to have more accessibility for the vulnerability report. You need to have a more complete SBOM, and so on and so on. So this is the reason why we created this requirement enhancement. And we didn't cover, of course, the others. For example, you have regular tests. You have different level of testing that you can do it. We don't want to bind the standard to some technique. So this is the reason why you don't find the fuzzing there. But maybe a product that is more critical, you expect that there are more fuzzing on it. And so we have also stand here for a site of another company that they have tools like that, or automation, other tools that they can help with this penetration test and vulnerability assessment activities. But this is just to give you a feeling of what are the difference between base requirement and requirement enhancement. Just here we are at the phase of, we had a public comment resolution. So we had comments from, this is a panel that I see in OSD, that is a tool that we use to do our standard. And as you can see, we had the first round of commenting, and now we are in the second round, and we received 1,945 comments. This is the one that is the round in blue. And as you can see, I also show you what are the comments, where they came from. So Haas is the one from the Commission, from ENISA and GRC. So we are not using Ernst Young now, so the process now is through ENISA and JRC that they are supporting with the commenting. And then you can have association like ANEC, Digital Europe, and the number of comments that we had of each of the member national standardization body. So let's just go and to have a look on the comments. So these are the comments from the Commission. It's a kind of summary of what are the main areas that we need to improve on the standard under their perspective. So in the PT3, we had a reference to PT1, and they say, no, you should not have a normative reference to PT1. You need to, if you want the presumption of conformity, because if we solve all the comments from the US, we will have the presumption of conformity, so it means that if you implement as a manufacturer PT3, you will be okay. So it means that you will be aligned with the essential requirement. If we don't have a presumption of conformity, it means that you are in the gray line on the interpretation. So this is the reason why presumption of conformity is important, because when a standard is cited into official journal, it's like a law. And this is the reason why our intention is to have PT3 mentioned, because if we have PT3, it means that the other standard can just refer to it. And this will be the main document that all the industry can use and to have the presumption of conformity. So they want us not to tie it with PT1, with 40,000-1-2, and it's okay, so we can have it as an informative reference, because you can have a different way to do a secure software development life cycle or a risk assessment. Of course, they want us to be more rigorous in the assessment methodology. They even mention 18,031, but on how to replicate conceptual assessment, sufficiency assessment, because sometimes we have in the assessment check that a policy is existing, but this is not enough. We need also to be a little bit more descriptive. So I agree that we need to improve a little bit more. We have the multi-party. We are referring to the standard of the multi-party that is ATR. What the Commission is asking to us is to not copy and paste, but to translate in our own words the main part of the standard, because of course otherwise you need to buy different standard, and so this is not what the Commission wants. we need to integrate as much as possible into our standard, but we will see how we can do that. SBOM completeness. The Commission says we have top level in the regulation, but we want you to go not only to include the transitive dependency, but you need to include also the known unknown. The concept of known unknown is in the CISA document. And they want us to follow that approach, even if there is also the market that is also arguing it's not the state of the art, it's the state of the art, but what the Commission wants is to raise the bar and to make sure that that will be the state of the art. Known unknown for the SBOM. Verification and triage. We have the concept of expedition of the vulnerability. We need to define better what does it mean expedite the vulnerability, but of course, if you have something critical, you want to have to solve the issue faster. If it's less critical, a little bit, you have more time. So this is the concept, but we need to define it better. We need to have update and distribution disclosure. So the Commission is telling us we need to put like 7 days. We need to be a little bit more prescriptive there not with specific dates, but we need to describe a little bit more what will be the disclosure process to the community. We have root cause analysis. There is also some comments that there was the part of the lesson learned. So if an incident happened, you need to have a requirement that says that you need to learn from that and you need to improve your secure software development cycle, for example. We had this clause, but we took it out in the last conversation because there were manufacturers that say it's too much, and now the Commission is asking us to put it back. So it's very hard because we need to balance a lot of interest and we need to understand what is really practical. And this is the challenge, is not to make the change because some of these changes takes minutes. The problem is all the discussion that are on the back. So I think that, Gabor, you know how much of this discussion, and you are also, we will discuss also tomorrow how to solve part of your comments about the receipt. And so thank you so much also for people like Gabor and others that they are putting a lot of effort to support into the comment resolution. We have terminology, we need to fix it. We have Annex ZA. It means that in the Annex ZA we did the mapping, but we forgot to contextualize better the requirement enhancement. We can do it, there's no problem. It's something that we introduced at last minute, and so we didn't integrate very well, so we will do it. And then they ask us also to have an Annex X. I don't know, we didn't call it yet, but it's a list of what are the risks that we are covering with our standard. We know it's a process standard, but of course we can say you need, for example, the SBOM, because you need to be faster in identifying vulnerability, for example. We can always create a list of this risk and we can put it there. I don't think that there is a problem. In fact, I offer myself to create one of these and we will discuss and we will integrate. This is the part that is also interesting for you because we understand the Commission what it wants. Here is a summary of the position of the national body. They are going left and right even between them. So we have all the national standardization body. Some of them, they say the same thing. Some of them, they are opposing. For example, requirement enhancement. So there are people that they like it, people that they want to remove. But if we remove the requirement enhancement, we remove the negotiation point between us and the Commission. So this is my opinion. Let's see where it goes, the conversation. We had a conversation this morning. And it's really a long negotiation process also for that. So we have the risk-based approach. Some of the national standardization bodies say that it's not systematic. We refer to rigor, but we didn't specify what is the level of rigor. Technically, we don't need to specify because everything is risk-based. It's the manufacturer has the responsibility to do the risk assessment. We just need to contextualize better and to make a difference between a regulatory risk assessment, product risk assessment, and how you then select the right level of requirement enhancement. Of course, here is our same point. Just to let you know, I didn't tell you what is the color code. Blue is the one that we have more conflict. White is where we are aligned. In fact, for the making PT2-1-2 as a not normative, everybody is aligning on that, so we can solve it very fast. The problem are the blue, that we have different position and conflicting statement. Maybe I can focus on the blue because this is just for the sake of time. We have documentation burden. Manufacturer says it's too high. We want to document. There are a lot of policy. Unfortunately, a policy doesn't stop a vulnerability, but without role and responsibility, if there is an incident or there is a vulnerability, you don't know who is responsible for what, and it's not a good thing. Then, of course, there is the policy content. Some of the national standardization bodies says that there is a lot of burden in how many policy you need to have. You need to have internal policy for the vulnerability handling, and you need to have external policy. Makes sense, but we need to see how we can calibrate that. SBOM, national standardization body, but in the law there is only top level, so we stop to the top level. And that's it. If the Commission wants to do more, they can create something more. But the point is that we need to understand that we need to raise the bar for everybody. Maybe we don't include the known unknown, but we can have a requirement enhancement regarding the transitive dependency, like it is now. Okay? The Commission wants to go a little bit over that requirement, more stricter. So we need to see what is the negotiation point. Because the point is that if we don't satisfy the Commission, we don't have the presumption of conformity. So this is the reason why it's a breaking point between these two negotiation points. We have the machine readable. People say, okay, it's not required, it's not so. But if you have a machine readable format, you can speed up the sharing of information within an industry like ISAC that you have in the industrial area or financial and so on, and then you can, or even the single reporting platform, you need to have it in machine readable, so it will be faster, the interaction. And then, of course, the evidence and the burden of evidence that the manufacturer needs to carry to demonstrate compliance. So, timeline, I will be faster, so I will give some time for questions. There are 3 minutes left. But the standard, if you see the standardization request, was supposed to be ready in August, 30th of August 2026. There is a delay, at least 2 months of delay, because we took some time earlier. Now we have a lot of comment to process. There is a negotiation process that is going on. And for now, the timeline can be optimized. So we are just trying to find a way how to do it better. For now, it's in December 2026, the publication. But the Commission asked us also to be faster and to understand what we can optimize. This is just to share with you that there will be some delay. We don't know how much. And of course, in my role as a rapporteur, I'm also trying to speed up this role because I'm assigned 100% now on these activities. And that's it from my side. So I want to give time for questions. Sure. 2 minutes, I think that we are around.
Thank you very much, Angelo. Any questions from the audience? Okay, if not, then I have a question. Angelo, do I hear correctly that the Commission created a legal text, and now to fit that legal text, to have presumption of conformity, they say you need to add more, the standard creators. And how can you tackle that? How is that justified there?
Yeah, so I think that the position of the Commission is say that is a risk-based approach, and for example, for the SBOM, they say that you need to list the top level. But you don't do so much with the top level. So, and the Commission is saying it's risk-based, but we need to embed this concept also in the standard. And I know that they are asking here, but I know also that the NSB, they are also going into the lower part. We need to meet in the middle. So this is the reason why it's a negotiation, and it will take a lot of time. But a good question, because this is what we are speaking about now in the course. Yeah. Thank you.
Okay, so we heard what are the documented requirements and background of the vulnerability handling. Now let's see how this looks like from a practical perspective, real life, and that will be told by Massimo Ratti here, who will show us an actual example.
So hello everybody, I'm Massimo Ratti, Product Manager of Security Pattern. Security Pattern is a cybersecurity consultancy company dedicated to device manufacturer. The aim of this presentation is to show you an analysis that we did about the vulnerability management process for device manufacturer. The results of our analysis is that the traditional vulnerability management process is no longer enough, and now I will try to explain you why. Let's start to analyze a bit the data that we have. These charts represent a bit the trend of new vulnerabilities discovered since year 2000 till 2025, about new vulnerabilities per year. If you look at 2025, what we can see is that in 2025 there were 48,000 new vulnerabilities detected. That means more than 100 new vulnerabilities per day. 40% of these new vulnerability were identified with critical or high severity, but less, let's say, than 1% of this vulnerability as a proof of exploitation. Now, let's try to map this data to a real case scenario. So we took a device, a Yocto-based device, a connected device, and we identified vulnerabilities in this device. The number that you can see basically are these one. So we identified 2,775 vulnerabilities. We prioritized, according to a standard procedure, the vulnerabilities based on severity, and we'd end up with 25 vulnerabilities with a critical severity, around 800 with high severity, and this means 834 vulnerabilities that has to be managed as soon as possible. What does it mean manage? Means applying the traditional vulnerability management process to evaluate if these vulnerabilities are applicable or not to the device. So basically, a team that is developing this kind of device has to implement, first of all, the identification that usually is automated, and then has to prioritize and identify the triage. So the 800 vulnerability that has been prioritized based on severity need to be triaged. You can imagine that considering 2 hours for each vulnerability at least to do a good triage, it's something that is not affordable for the majority of device manufacturers, for small and medium enterprises. Why it's not, it's too much? Because critical and high severity, as I said in the beginning, are the main, let's say, majority of the vulnerability are identified as critical and high severity. So triage becomes a nightmare, and it ends up with a big delay in a firmware update release, and firmware updates, as I will show you later, are less effective. So what is the main point here? The main point is that in our view, CVSS is useful to measure the potential risk of a vulnerability, but is not sufficient for prioritization. We think that the context, especially for device, is more important than the severity score. What I mean by context is that a vulnerability, the same vulnerability that can have a high score for a device that is connected to the internet is not that important, maybe if the device or the hardware that is executing the software is not connected to the internet. Exploitability is another topic that is, in our view, is more important than the amount of vulnerability that you are able to manage in your process. So fixing 50 vulnerabilities that are just theoretical from a security standpoint is less important than maybe fixing 5 vulnerabilities that are really exploitable in your device. Another big topic related to context when we are talking about a device is that a device is not just software, it's hardware also. There are hardware components involved in the analysis. Hardware components that are microcontroller, microprocessor that execute your code, memories that store data, that store cryptographic key, but also Bluetooth, Wi-Fi radio module, secure element, trusted platform module, and so on. A vulnerability management process that does not include hardware in the analysis is not complete. Why? Because hardware components are managing important assets of your company. Hardware has vulnerability, and so you have to take care also of this vulnerability. Another important topic is that if you consider hardware also, you can speed up the analysis of vulnerabilities. Why? Because some hardware component is not exposed in the same way to attackers, and so you can exclude immediately software vulnerability based on the exposure of the hardware that is executing your software. I try to be, let's say, more, to explain it better later on in another slide. So what we envision is a slightly different vulnerability management process. So basically all the gray spots are the same of the previous slides. We have implemented a new, what we call a pre-triage step. In this pre-triage step, we automate the exploitability evaluation. So basically what happens is that in this automatic step, the machine is capable to identify what is high priority based on some proof. Which are the proof that we are looking for? First of all, proof of exploitation. There are evidence that you can find in the specific database that says that if a vulnerability has been used to attack a device in a real case scenario. This kind of vulnerability are important, so must be prioritized independently of the CVSS score. Then there are other databases that collect exploits that are used by penetration tester, for example. So if we found an evidence that a weaponized exploit can be used to attack a device based on a vulnerability, we bring this vulnerability to a priority, saying this vulnerability has high likelihood of exploitability. Another element that we use to classify vulnerability a priority is identifying if the hardware that is executing the vulnerable software component is exposed to an attack, and in this case all the vulnerability are, let's say, are applicable to enter in this high priority category. Otherwise, all the other vulnerability are, let's say, can be temporarily accepted and considered low priority. Why I say temporarily? Because basically this kind of vulnerability must be continuously reevaluated to understand if after 1 month, few weeks, or few days, there is a new proof of exploitation that bring it back to the pre-triage step and ask an immediate triage. So the idea is that this process should be continuous and should be automated in order to reduce the amount of vulnerability that go to step number 3. Now, let's come back to the original example I did on a Yocto connected device. So we had 2,075 identified vulnerabilities. In the traditional, let's say, procedure, the prioritization is based on severity, and so we end up with 834 vulnerability to be triaged ASAP. If we implement the, let's say, the improved process that I described in the previous slide, with a prioritization based on context analysis and exploitability, we end up to have only 10 vulnerability to triage ASAP. So you can immediately identify the difference between the two approaches. One is affordable even for small and medium enterprises. The other one is really complicated. Again, I want to say that testing the 10 vulnerability doesn't mean that all the rest of the vulnerability are forgotten. They are just kept aside, continuously monitored until when there is a proof of exploitation. Only in that case, we raise a flag and we inform our customer that something must be done immediately. Last thing that I want to highlight to complete the analysis of vulnerability management process is that vulnerability management process is an organizational process. It's not something that must be implemented by developer. This is, in our view, the main mistake that we see in our customer. Vulnerability management must be led by product security. What does it mean? That the product security team initially define which are the criteria to prioritize vulnerability and do the first triage. Only at that point involve the quality team. The quality team will check the regulatory impact of the vulnerability that has been identified as important. And only at that time developer enter in the scope, and only at that time the developers try to find a fix if needed, because the developer can identify that the vulnerability at the end is not exploitable for any reason. When the developer finishes, the product owner decides with which pace the software update must be released. So it's clear that the problem here is the real problem of vulnerability management is the coordination among all these roles inside the company. All the roles inside the company that are involved in the vulnerability management process needs to have access to this information. So again, the tool that analyzes the vulnerability is not a tool that must be installed in the developer PC, because this is the main mistake that we saw in our customer. This is a bit the reason why, the main reason why we decided to implement Arianna. That is a platform that with the aim to help our customer to fix the right vulnerability faster. How we are doing that? Again, we are providing the support to create a device model. So the device model is a model that helps in creating the HBOM, so the hardware bill of material, and the software bill of material, defining which hardware components are executing on a specific piece of hardware. This will help to identify which are the attack vector exposure of each piece of hardware and on the relevant software that is executed on top. We implement a continuous vulnerability monitoring. We automate the vulnerability prioritization with the criteria that I described before, so based on exploitability. And we made this platform a collaborative platform where multiple roles in a company can put their own value. All the stuff that I mentioned, so the concept of exploitability, the concept of HBOM, are not something that we created. It's something that is mentioned in regulation. For example, RED mentioned the fact that you have to put on the market devices without known exploited vulnerabilities. So there are no regulations that said you have to fix all the vulnerabilities. They are not mentioning the severity, so CVSS3 again cannot be the only way to prioritize things. They are mentioning known exploited vulnerabilities. So when we look for proof of exploitation, we are exactly in the same direction. They are mentioning also the fact that it's not only the software the important thing, but also the hardware must be analyzed, because hardware has vulnerability as well. And the same thing can be found also, okay, now I can come back, also in the CRA. CRA is less focused on hardware, but again, hardware we think that is in any case important to better identify which is the context and to better triage the software vulnerabilities. But also CRA is talking about known exploitable vulnerabilities. So that's why prioritizing based on exploitability is the right thing to do. So I try now to summarize a bit all the messages in this presentation. So we have to rethink a bit the vulnerability management inside the device manufacturer context. So the number of vulnerabilities that are increasing year by year are not the problem, but the bad prioritization is the real problem that device manufacturers have to face. They need to shift the focus to vulnerability decision intelligence, so they have to create a prioritization criteria that help them to identify the real important vulnerabilities, and so CVSS is not the right things to go. Hardware model is critical for vulnerability decision because it helps to create a context where the analysis can be improved. And vulnerability management process is not a technical task, but is a task that must be led by product security. So these are the main messages that I think it's important to pass. So if you have any question.
Yeah, two questions. So 62443 and the CRA itself tells you should be implementing the testing of your software in a CI/CD pipeline.
Yeah.
And very often in the industry, we have seen that security has been always left into the end of the development process. And that creates a ping pong between developers releasing software, someone testing it, sending it back, and this back and forward is not effective, it's costly. CRA is already rising the bar on the complexity on testing the software. Now, I heard you loud and clear saying that developers should not be involved in handling the vulnerabilities. Those concepts, from my point of view, are conflicting. So can you clarify that?
Yes.
And the other question, so
yes.
I can shut up then.
Yeah.
How do you detect these vulnerabilities with this Arianna solution that you are proposing?
Okay, so let's start from the last question that is easier. The last question, so how we do that? So basically we create a model. We start the creation of the model from the hardware. So we provide an interface to the device manufacturer to list all the part number of the relevant hardware components, as I was saying, microcontroller, microprocessor, and so on. Then when the HBOM is ready, based again on the part numbers, we provide tools to software composition analysis tool that must be executed in the CI/CD pipeline at the end of the build process that will extract information about the software components that are used, that are included in the binary. So we are not doing binary analysis, we do the analysis of the software at the end of the build procedure. There are different strategies depending on the system that you are using. So we have a strategy for operating system like Linux, another strategy for Windows, another strategy for a free RTOS-based system or bare metals. More or less, this is the way we do. Once we have all this information about the software, everything is uploaded on the platform, and the platform finds a correlation between the list of hardware and software components identified and the vulnerabilities that we are grabbing daily from public databases. I hope that I replied to your second question. Concerning the involvement of developers, what I think is that the only way one step back. In a system like the one I showed you before with 2,000 vulnerabilities, the developer, which is the only way the developer can fix them? The best thing that they can do is to update the system continuously. So they identify that they are using a software components with a vulnerability, or they implement a patch, but most of the time they will find an updated version of that component. This is a continuous process, so this 2,000 vulnerability will never be fixed completely, but the developer itself has no a clear understanding of which are the assets, which are the problematics that imposed by a regulation. So this is something that must be done by an upper role, like a product manager or the cybersecurity manager of the company. And only when the priorities are being defined, that maybe are less than 1%, only the time the developer is involved to try to find a fix and to analyze it technically if the attack can be implemented or not. So maybe I was too strong in expressing this concept. I'm just saying that the developer should not lead the process. Developers are involved only in the final stage of the process. Initially, the decision on which are the priority must be made by the product manager, the cybersecurity manager, that has a bigger, let's say, a higher overview of which are the assets to protect and which are the risks exposed.
Thanks for the presentation. You said that we can exclude the vulnerabilities from that have been fixed by component vendors. Is that something easy to know? I mean, how do you make this, how do you say, surveillance of components having addressed the vulnerabilities?
Correct. So there are different approaches. They are very technical. So let's say that there are, as I was saying, we are providing, to create the model, we are providing a software composition analysis tool. And this tool, they are different according to the system that you are using. So we have a tool for Linux, a tool for Windows, a tool for RTOS-based system. Each ecosystem has some advantage, some other ecosystem has disadvantages. If I took into account, for example, Yocto, that in my view is one of the most advanced systems for vulnerability management, in Yocto, you will find clear information on which are the components included in your binary without doing any reverse engineering. So at the end of your build, you can detect what is included in your binary. And you can also detect which are the patches that has been applied during the build process and which vulnerability has been closed with these patches. So it's important to extract this kind of information while you are creating the SBOM, because this information will result in a final report with a lot of vulnerability already closed because are, let's say, maybe applicable to your components, but you already have a patch, you already applied a patch during your build process that excluded. So what happens in our system is that we present this vulnerability to you in the final report, but we presented it as patched. So if someone reports this vulnerability to you, you can say, yes, I know that I have, but has been patched during the build process. Other evidence can be found in, if you go, since we are monitoring hardware, we are keeping track also on security advisory of a silicon vendor. Silicon vendor in their security advisory sometimes state that a certain vulnerability that is reported in public database is not applicable for specific reason to their hardware. So this is something that we do.
Okay, thanks.
Any other questions? If not, I do have a question. What did this Yocto device did in practice? Because we just call it a Yocto device, and that was interesting. And the second one.
So sorry, the question is what was doing that Yocto device?
Yeah.
Okay.
And the second one is, did you actually search for a long time to find a device with this many vulnerabilities, or this is the
to be
normal
honest,
level?
is a device of one customer that we have. So I extract this data without mentioning who is the customer. So it's a power supply unit that is based on Yocto. And so let's say that in this case it's an industrial device. They are not aiming to update continuously because every time otherwise is a new process of testing. They have to repeat a lot of things. So if there are no good reasons to update, they prefer to keep the initial version, but they end up with 2,000 and something vulnerability.
All right. Thank you. We still have a couple of minutes if somebody has any question ideas, because we will wait until the given timeline so that others can also join the next presentation.
Thank you. Well, first of all, I want to say that I agree that not only the technical team and development team should be involved in the risk analysis and determining which vulnerabilities to address, but also the product team and even legal team and everything. So I like that structure that you suggested there. My question is, I want, perhaps if you can tell us a little bit more in light of the reusable components. Let's say a certain product that uses this component that has a vulnerability, may be exploitable and may be exposed to some risks. Another product may use the same component, but it's not exposed. So how do you bring the use case into the risk analysis in this case?
Yeah, it's one of the biggest topics that we have with our big customer, because exactly, they have teams that are working on a device. This device, the team that developed the device do an initial analysis saying this vulnerability is not applicable, this vulnerability is acceptable from our point of view. But then this device inside the same company is integrated in bigger systems. So they were saying, I want to reuse the analysis done by the initial team. And we say, no, it's not possible. Why? Because basically you have to take the S-bomb and the H-bomb provided by the team that developed the device. But then when you integrate it in your system, you need to repeat most of the analysis. Okay, if the initial team says it's not applicable, it's not applicable. But if the initial team says it's acceptable, you have to reevaluate it, because, so basically when we transfer this information, we just say, according to the initial team, to the original team is acceptable, but you need to reevaluate in the context of your system. So as you were correctly saying, if inside the same company or outside the company, the same device is used in two different systems, the team responsible of the two systems need to repeat the evaluation to say if the risk is acceptable in their context or not.
Any other questions? Then, if not, thank you very much, Massimo. And we still have a couple of minutes, and I suggest that we wait a little bit, because otherwise others cannot join the next presentation. Okay, thank you very much for this wait, and to allow others also to join us. Now the next talk will be Converging Vulnerability Management and Risk Governance under EU Cyber Resilience Act, and will be done by Dr. Rituranjan Srivastava, who is CISO and Thought Leadership Director.
Thank you. Thank you, Gabor. So hello everyone to the last session of this track. You made it. So actually I prepared some slides. It's mostly applicable to manufacturers, developers. So I don't know how many of you are here. But you have seen, I mean, I heard in a panel that somebody was saying that regarding CRA, we were baby, and then now we are toddlers, so we're starting to learn how to use it, how to implement it. Actually, so we are in a very good transition phase, And we don't have much time, so 2026 is a very crucial year for being prepared, starting to put all your systems in place with regards to vulnerability management, all your policies, processes, quality management systems. So being part of CRA, which recently got acquired by Cadence Design System, I have been working for many years to uplift the organizational cybersecurity management in this company, from the product to the process, so navigating through the challenges that comes into ensuring multi-certifiability in the products, and also ensuring that the organization is at a good level of cybersecurity maturity in terms of risk analysis, risk mitigation, vulnerability management, etc., which is basically the crux of the CRA. And of course, security by design is something that is no longer a good for good to have. It's rather something built in, baked in inside the CRA. So something interesting also about the acquisition I wanted to share. So Cadence being a US company and CRA being a French company, this acquisition was a little bit special because CRA being a security IP provider in France, and being a provider for defense and other critical applications, requirements were to ensure accessibility to technology within the French governance. So that was a kind of a very critical phase to navigate. But somehow over the last year, so we managed to find a right compartmentalization for data, ensuring that there are no ETAR, EAR regulations. So it was a real and actually one of the biggest organizational level cybersecurity management that we had to put in place, along with continuous monitoring. So it's very much, how to say, in line with how you can, in one way, estimate the overall maturity of an organization with regards to cybersecurity posture. So I prepared some slides, like I said, mostly for the developers and manufacturers. So the purpose is, with CRA, we are supposed to adopt it very quickly, be prepared, of course, from the standards point of view, from certification bodies, the standards, who make the standards. So you have been hearing about it, and you know about all the different annexes and what are the essences of the CRA. But what it means to actual developers, to actual manufacturers, so that is something that we can try to find some synergies with some existing models that we know of. For example, people were talking about 62443, 21434. So in this, basically, I try to bring some small synergy, try to draw some synergy with the UN regulation 155 and 21434, and use some existing standard tools like the RASI or the RASIC, for instance, and how we can actually ease this process and make the adoption easier for manufacturers, okay, from both the product as well as the organizational cybersecurity, posture-wise. So I'll talk a little bit about what the threat means to security product manufacturers and for the developers, and how we can really instantiate the continuous vulnerability processes. So what we did also as part of CRA, so what we are still doing to ensure this conformity, and then some synergies with some strategies to get EU CRA compliant for security IP or security product manufacturers. So as you all know that this year is the transition phase, so we will be obligated for the reporting by end of almost in the third quarter, end of third quarter, and the full applicability is next year. So this year, that makes this year a really important year for making all the systems ready, so all your vulnerability management processes and everything to be in place, okay? And that means you have to upgrade not just your products, but also your processes. Like if you have some quality management systems, you need to ensure that there are processes in line that is tied up with your policies that does not violate some way your businesses. So how to ensure that alignment exists. So in our case, in CRA, so we build critical security products. So here we already follow some standards for product security. And of course, from the organizational point of view, we also ensure like a processor like PCERT and so on. So this is already in place. So how we can leverage that to create a path to get EU CRA compliance. So this is what my objective is in this talk. So what are the baseline obligations? So you already saw this in many slides before. So what we really need to focus on in this year are those obligations. So risk assessment. So what exactly is risk assessment? So it is actually, you can see it in two different ways. So one is for the product and one is for the process. So you also need to place yourself in the whole supply chain view, okay, and ensure that when your product is entering the supply chain, what are the risks that can emerge in the later stages in the life cycle. So, and ensuring that you cover those aspects as well in your risk assessment. And of course, from the organizational point of view, you have the information security management system that you need to put in place. This can be covered, for instance, by the common criteria already provides something called the ALC DVS, development security. So you can get site certified, or you can, which is basically the minimum site security requirements, or ISO 27001. There are many such frameworks that can help you, scale up on that front. So this supply chain risk analysis is really, really important. And then, of course, vulnerability management and vulnerability handling processes that you need to put in place. Of course, when you the standards that I'm drawing synergy from here today, it's basically automotive regulations and standard. So 21434 is for cybersecurity of road vehicles. So you know already about the V cycle development process. So in this process, so you start from the requirement, and this is already kind of built-in framework to enable really the security by design concept, okay? And there is a requirement in terms of patch management, vulnerability management by instantiating a PCERT team that can actually do continuous monitoring and ensure the fixes are and the patches are provided on time. But CRA actually defines some real obligations in terms of timeline as well. So we'll be seeing that in the next slide. And of course, the other legal obligation from the CRA that originates from reporting is really crucial. And this is also covered in CC in a way, so the flaw remediation, so ALC FLR. So in a way, you can see that by certain assurances from different standards, by utilizing those tools, there is you can start to see a path towards the CRA compliance, which is basically about identifying your critical assets, which in CC terms as the CSPs or the SSPs, the critical security parameters, sensitive security parameters, and then try to find the security requirements from the CRA that applies to those assets. Okay, so you understand your assets from your organization and product point of view, apply those security requirements, and put in place a vulnerability management process and do a reporting as per the CRA obligations. So these things are really important to really achieve by this year to be prepared for the CRA. And of course, after that, you already saw in other presentations about the module B, module H, so module B plus C in a more EU format where you can do a conformity assessment with a notified body for your CRA compliance, and then you prepare the declaration of conformity with the CE mark, etc. So with regards to the operational obligations in terms of vulnerability management, so there are some really very concrete deadlines, I would say. So in traditional PCERT or vulnerability, so this is something that is managed between the supplier and the manufacturer. So it depends on the agreement. It used to depend on the agreement, but CRA really made it real. So they have quantified some real obligations. So for any incident or vulnerability that is identified must be reported as early as 24 hours. Then, the final, if it's a severe vulnerability, so final report should go in less than 1 month. So You can imagine from a manufacturer's point of view, so why this is scary. Not really scary, but if you have the real process in place, it becomes really possible. So because in this 1 month, you need to ensure that all the 4 stages of the PCERT process is ensured. So you have the ingress where you actually receive the vulnerability, so incident reporting, to impact analysis, to triaging and everything. So, and then of course, the remediation plan and the fixes and everything, and final reporting. So these obligations must be met if you are trying to get compliant to the CRA for any security product. A little bit stepping back to understanding what threats and vulnerability means, because in the end, so you need to ensure, you need to identify or understand for your company, if you're a manufacturer, like what are your real assets in terms of product or your, as an organizational assets, and to ensure you have the real vulnerability management in place. So I think in the previous presentation also we saw that risk is not in the typical the traditional way. So it's not just the threat or the vulnerability. You need to do impact analysis. You need to see the applicability, the feasibility, the application, and so on. So, I mean, already the common criteria or the protection profile in common criteria provides that kind of perspective, where an asset is the unitary, basically the unitary security parameter from a product and organizational point of view, okay? And a threat consists of an adverse action performed by a threat agent on an asset, okay? And therefore, vulnerability is the weakness that a threat can exploit. So overall, the cybersecurity risk can be measured by the threat with the vulnerability and the impact that it can cause, okay? Why this is important? Because it's the asset that you want to protect in the whether be it a site-related asset or whether it be a product-related asset. So this is something that we need to map in our minds. So the CRA already gives us an obligation to make the security by design. Okay, that means no longer end of V cycle, do a security analysis, do again an agile process to go back and redevelop. So that no longer works anymore. So it has to be integrated in the design, in the requirement stage, in the left side of the V cycle. So it goes in as a requirement, and you have the security built in. And of course, after that, you have to put in place the vulnerability management for the post-deployment. So this is something that you are protecting your assets, organizational as well as your product assets. That can be, keys or your firmware in the ROM or whatever. And then, of course, the physical security of the site where the product is itself developed or manufactured. So this is from a regulatory point of view and the standard point of view, this is how we can combine the protections and treat the risks. Then, what is the real path to CRA? So, is it really some way? I mean, there are many ways to comply, and this is what we are still. There is no clarity yet, but based on the discussions yesterday, I had some interesting talks with some people, some presenters. So basically, what the real question is: what are your security assets? Okay. And based on that, what are your security requirements, okay? And once you know that, you can actually identify your product falls into what category. Is it a critical product, it's an important class 1, class 2, etc. And then, of course, you need to have that obligations put in place, your legal responsibilities for reporting, for vulnerability management, continuous management, etc. And how to achieve all that from what we already know. So we know common criteria. We know 62443 UN regulation 155, this 21434, we know about them. These are all process-oriented or already mature enough standards that provide us the framework for vulnerability management and product security, right? So for instance, the eBIOS is something of a risk manager. It's a tool provided by ANSSI in France that has the capability to perform risk analysis from organizational as well as from product point of view. So once you do this, you have the cybersecurity risk analysis done, okay? And then you put in place all the necessary measures, okay? And of course, with that, you need a PCERT, okay? And of course, the flaw remediation, the ALCFLR component in common criteria provides a vulnerability management process in which PCERT also falls into that. And of course, obligations in terms of legal bindings from CRA, it requires standard legal reporting structure. So maybe that's not so obvious in the ALCFLR2, so that's something additionally you need to do. And of course, from the site perspective for your organizational or corporate assets, so that is covered by, let's say, ISO 27001 for ISMS or ALCDVS2 for minimum site security requirements that covers your development activities, how you manage the assets internally within the company, for example, how well you define. So, for example, sensitive, critical, very critical, those kind of differentiations for the assets. And what measures do you have in terms of physical security, logical security, network level, etc. So access control and all those things. So with this kind of path, this actually can lead to a mapping to the horizontal standards, the harmonized standards that we have today, and can lead to your compliance or conformity for CRA compliance. Of course, you need to go through the module H or module B conformity assessment with the notified body, etc. So then, of course, with regards to the continuous vulnerability management, what are the different steps? So in a standard PCERT, what we see are the 4 major steps: is the ingress, analysis, fixing, or remediation, and then the egress. So basically, this is a cyclic process, and this is what it means about the continuous vulnerability management. It's, and this is basically very much aligned with what IEC 62443 or 21434 require. So why really look at the UNEC regulation number 155 or 21434? Because they are mature standards, of course, and regulation 155 provides kind of a very mature organizational cybersecurity management system concept that is, that requires evidence for vehicle type. So this is more from deriving how to say, this is derived from the automotive market. Okay, these standards are applicable to automotive, but it's not about one-to-one mapping, it's rather about understanding the concept, okay, and how we can really apply to our existing organizational structure to ensure compliance to the CRA. Based on the product type, it might vary a little bit, but it's about the the mechanism. So if you understand the logic, it's straightforward, I think. So the most useful inferences that we can derive from these is risk-based decision making is something very essential. So once you have a mature cybersecurity management process, that means you have it in your quality management system. That means you have a standard process and a workflow where you can take real decisions with regards to the vulnerabilities or incidents. Then you have a mature PCERT process where all the vulnerabilities identified in field are treated well. You have the process, and therefore you can serve the obligation of the 1 month duration that the CRA requires. And of course, traceability is something really essential. So having security by design, having security implemented as a part of your V model development is going to give you the traceability of requirements down to your source code. This is really essential. So I try to create a kind of mapping. It's not really a one-to-one mapping, but rather how to understand the logic in this regulation 155 and the standard 21434, how it is kind of similar. So CRA is not, I'm not saying CRA is deriving from these standards, but rather, again, so we understand the existing regulations or standards, so how well we can adapt our current processes, our current posture of organizational level cybersecurity maturity, etc., to use CRA compliance. So that's where these things really help us. So in terms of risk assessment or life cycle coverage, so we already see in regulation 155, it's about the whole life cycle coverage, and also with regards to monitoring or how we handle vulnerabilities, etc. So like 21434 is completely process oriented. So it provides along with the 26262, so it's for the road vehicles. So there is a process that originates from cybersecurity policy, and then down to the TSF, target security functions. And also about accountability. So again, so this is, the CRA is very manufacturer centric. So this is why I think this is something more interesting. It's an example of what we already see in existing standards like 26262, 21434, and many others also. So you already are aware about the RASI or the RASIC. It's about responsibility distribution. So of course the manufacturer is accountable, given from the CRA perspective. Manufacturer actually is the implementer of the obligations. So, and of course the supplier is sometimes responsible, let's say for the root cause analysis or for the patch or remediation plan, etc. Then again, so the BCERT or the security team, of course, it comes as part of the manufacturer, but it's not a legal differentiation. It's more like a functional separation for operational ease. So to understand from an organizational point of view, coming from a compliance background, so you need to ensure inside your company, what are the teams, how you aggregate. So another talk was talking about who are the people in your company. So are you working with your legal team today in your company or not? But you will have to soon, because CRA is not just about engineering implementation. It's a much broader responsibility. So how to well, divide the responsibilities like that. So from a manufacturer's point of view, so this kind of RASI structure, which let's say in 21434 we know it as a cybersecurity interface agreement or distributed interface agreement in 26262. So this kind of frameworks that we really already understand, we can apply. And from that perspective, we can take it to our internal organization and execute those steps. That makes life a little bit easier. So again, so CRA requires assurance continuity. Okay, so like almost in all presentations, I'm seeing that it is mentioned that security case does not end at the security product release. So this is what CRA is about. It's about responsibility beyond the deployment, so until the end of life and even beyond, I think. So how we can do so? So this is about the traceability. Okay, so basically assurance continuity can be ensured by putting in place a continuous vulnerability management process, for sure, a good patch management process, and ensuring that the manufacturer is responsible for in-field updates, and of course the risk decision, remediation, and so on. So these are all part of the continuous assurance. In short, so CRA, it's basically making vulnerability handling a legal life cycle obligation. So it's no longer a maturity that can be measured. It's something that all the security product manufacturers must ensure to have. And automotive regulations or standards really that have a mature frameworks can be utilized for manufacturers who today are struggling for the CRA compliance, can take this, get inspired and apply that for their CRA journey. And convergence is possible. I mean, if you're already having an operating model in your company, for instance, for compliance to those standards, so you can actually reuse certain activities and reinforce them towards the CRA obligation. So. Yeah, so traceability, ownership, responsibility, etc. And that's it. So, any questions?
Any questions from the audience? If nobody has a question, I have a question.
Please.
Ritu Ranjan, what I hear now is that you already applied a lot of processes, you looked at them, did a gap analysis on CRA and found out that you are already ready?
Almost. So there are still small caveats that still need to, but the good thing is that we have a lot of our teams, starting from product to legal, everybody are really mobilized. and we are really working towards this direction. So it's becoming easier and easier. So we have a separate risk management team who is actually working on the organizational and product risk management. We are doing the EBOs continuously. So, and we also did cyber diagnostics and so on as part of the FDI process last year. So basically, yeah, we are in a very good shape to get CRA compliant very, very soon. Yeah.
Okay, thank you. Any questions? If not, then I thank you very much for being here and listening to these vulnerability handling and management topics. This was a very good session, and in half an hour there will be the closing panel of the conference.